into a new week. We are on the home stretch. You are in May, and so we've got 2 solid weeks of lessons left, and then we'll have a week where we'll have some testing at the end. Last day of school is May 21st, and your math test will be on May 21st. The plan is that it will just be a chapter test. It won't be like a final exam. So just be prepared. You'll just have a chapter test on that Thursday, and you'll be all set to go. You're going to have to pardon with my allergies. It's that time. So we are going to get started on 11.6. So we began last week, and you worked with some graphing and different forms. We're going to talk about slope today. So as we continue to work with these equations and work on graphing, you need to remember that there are different strategies. Okay, we've learned last week we could make a table, and we did that. Now we're going to learn about slope, and we're going to learn another form this week called slope-intercept, and it's another way to graph the equations. Now, as we do that, recognize no matter what method you choose, your answer should be the same. So I'll do a few with different examples, but you at some point will be able to choose the method that works best for you. With slope, the first thing you need to know, and if you don't have a notebook to write down, it would be great. Get your book out, page 612, 11.6. Take some notes. All right, so this is the note portion of our class. We're going to talk about slope, and I'm going to get a marker that writes better. And there are various ways to explain slope. What you need to know is when we will have an equation, the letter M will stand for slope. Okay, we can define slope in several ways. Okay, sometimes we talk about slope as rise over run. So when you're looking at a graph and you have a line and you want to find the slope of the line, you're talking about the rise, how much it goes up, and how much it goes over. Okay, that is the slope. How much it goes up and how much it goes over. So another way to talk about that is the change in y over the change in x. This being the y-axis, and the x-axis, the change in y over the change in x. This is where we get our formula for slope. So we're going to write our formula to find slope as y2 minus y1 over x2 minus x1. What we're saying is we'd pick a point and another point down the line, and to find the slope, we'd write the coordinates, and then we'd take we'll call this x2 and y2, this one minus this one, over this one minus this one, and that will give us our slope. So let's see what we're going to talk about. It'll be real important for you to be careful of signs when you are calculating slope. Most common mistake, kids don't pay attention and miss a negative sign, or miss that 2 negatives turn to a positive. So hopefully you have these notes. If you don't, pause it, write the notes down, and then pick it up again, because I'm going to erase it. And we're going to start with some examples of how to find slope. I'm going to actually leave that there because it's not too bad. And in your book, if you're following along, you can look at slope a few different ways. You may have a graph. So if you look, I'm not going to walk through all the examples with you because you can see those for yourself. If you look on page 613, you can see that they have a graph there. So what I do want to do is do a line there and just discuss this, but I'm not going to do a lot of examples with it. But I want you to see how it works in case you're struggling to picture that. So they give the graph in little a. All right, and they show that graph, let's say, going up this way. You can pick any 2 points on the line, and it will give give you the same slope as long as you pick 2 points on the line. And for this one, they have a point at 1, 2. All right, and they have another one at 5, 7. And we'll just say it's up here, right? We're going to pretend. So this is 1, 2, and this is 5, 7. Now what you're looking for, when you look on a graph, you want to find points that are right on the corners of those squares so you can tell exactly what the number is. If you look at a line, and you can see on little a in example 2, you know, the line certainly is before the point at 1, 2, but that's clearly where it's on the corner of that grid. So that's what you want to do. Look for points that you can see clearly. Okay, so how does slope work? We're going to take y2 minus y1. So I'm going to write that out. Over x2 minus x1. Okay, and we get 7 minus 2 is 5. 5 minus 1 is 4. Okay, so that's the slope of that line. Now let's say, well, what if I call this y2 and this y1? Okay, 2 minus 7 and 1 minus 5. 2 minus 7 is negative 5. 1 minus 5 is negative 4, and my slope is still 5/4. Okay, as long as you're consistent with your signs, it will come out the same. One mistake I see students make a lot is they'll do 7 minus 2 and then 1 minus 5. It's important that whichever point you start with and call this the second or the first, you keep that consistent. So, if you're given a graph, you choose 2 points and then you use the slope formula. Let's look at number 2, guided practice, page 613. I'm going to go ahead and cover one more concept. I was going to wait till I got to one example, but I'm going to go ahead and cover one more concept here, and that is horizontal and vertical lines. Now you've worked with graphing horizontal and vertical lines, right? And in this case, let's say this is over at 3. This is x equals 3, all right? This is up at y equals 4, all right? So remember that x equal lines are always vertical lines. Hopefully you can see that. Y equals lines are always horizontal lines. That's very key to remember. Now, what we have when we have those is zero slope or undefined slope. Okay? When you have a y equals an equation, you're going to have their slope. I need to use the darker marking here. Sorry about that. This slope, y equals, the slope of this line is actually 0 slope. And we'll see that when we calculate it. But a y equals horizontal line is 0 slope. And x equals a vertical line is undefined. Okay, this is not 0 slope. It's a vertical line, and its slope is undefined, not 0. So, hopefully you have your notes. That's key to put in your notes. And it should be quick for you to calculate when you're taking a test or doing a practice problem. Oh, it's y equals negative 2. Oh, that's a 0 slope line, okay? As soon as you see those. So, now we'll go to the guided practice on page 613. Now that you have these under your belt, make sure you do have these notes. It's very important that you have those. If you've missed them, you can look in this section. Let's do some practice problems. We're going to look at guided practice page 613. Let's go ahead and start with number 2. And your coordinates are 2, 1, 6, 4. Oftentimes, I do this to help me remember. This is y2 minus y1. x2 minus x1. 4 minus 1 is 3. 6 minus 2 is 4. My slope is 3 over 4. Okay? Meaning, I go up 3 over 4. Now, that doesn't mean a lot to you now, but when you're learning to graph and putting this on a graph, this is your up and over. All right? So if I'm looking at that, I'm thinking, okay, my slope, I'm up 3 over 4. And those are both positive. Let's look at another one. We're going to go to number 3, 0, 6, and 10, 0. Again, y2 minus y1, x2 minus x1. So 0 minus 6 over 10 minus 0. 0 minus 6 is negative 6. 10 minus 0 is 10. You always reduce slope, so you're going to keep going until you have it as simplified as possible, and that is negative 3 over 5. Now I'm going to tell you, what does that mean when you graph? That means instead of, because this is negative now, I'm going to go down 3 over 5. So think about that. Just as you're doing this, you want that concept in your head. This is the rise over run, the definition we talked about. So this is down 3 over 5 when it comes to that. Let's look at number 5 on the guided practice. 1, 5, negative 3, 5. Okay, again, 5 minus 5, negative 3 minus 1. 5 minus 5 is 0. Negative 3 minus 1 is negative 4. So, 0 divided by negative 4. Is that possible? It is. Okay, this is where kids get confused. I can multiply negative 4 times 0 and get 0. So this is a 0 slope. If you want to pay attention here, when the 0 is in the numerator, it's a 0 slope. Okay, so you can know that that line would be a horizontal line. That is a 0 slope when 0 is in the numerator. Let's look at number 6. The coordinates 1, 6 and 1, 2. Okay. Again, y2 minus y1, x2 minus x1. 2 minus 6, 1 minus 1. So I have negative 4 over 0. Here's where you need to recognize. What can I multiply 0 by to get negative 4? Nothing. Remember in the previous one, I can multiply negative 4 by 0 and get 0, my numerator. I cannot multiply 0 by anything and get negative 4. Therefore, when 0 is in the denominator, that is an undefined slope. Undefined. It's going to be a horizontal line, right? I'm sorry, a vertical line. Undefined slope. It's going to be a vertical line. So when 0 is in the denominator, your slope is undefined. Okay, so that works through the example on page 613. If you look over on page 614, it's great to look at those diagrams there. That's your key concept box, and it really helps because it shows you when you look at a slope, you look at it, when you look at a line, you look at it going left to right. Okay, so if I have my axis, I'm looking at this line left to right, and as I move left to right, it's going up, it's positive. When I look at this line going left to right, it's going down. So I recognize that is a negative slope. They show you there, okay, 0 slope. And again, the undefined vertical line. Okay, so Recognize when you look at these lines, oh, it's going up, that's positive. Left to right, it's going down, that's a negative slope. That is important to remember. You have mostly what you need to work through this. I want to work through one more example with you, which is not an example, but I'm going to look at a harder problem, and I'm going to look at number 28 with you. Okay, after I stop dropping my markers. All right, I'm going to look at number 28. And this is a challenge. So for all of you good thinkers out there, if you're willing to kind of challenge yourself this chapter, I'm going to have some bonus questions at the end. So if you're getting these concepts, that is awesome. And so here's a little bit of a tough thinking concept. So it says, all right, M, which remember, stands for slope, okay? M stands for slope, and it tells you M, I lost my place, is 7/4. And then it says, here are my coordinates. I don't know this one, but my y is -7. And my other coordinate is 16, 0. And the slope of those two lines is 7/4, okay? So what I'm going to do is use those coordinates and plug them back into what my equation would be, all right? So I have this one, 0 minus 7, there's where you have to be careful with your signs, and 16 minus x, okay? But one more piece of information is important. I know that that's going to equal 7/4. Remember, minus is plus. So I have 7/16 minus x equals this 7/4. Now, this is a fairly simple one because most of you are like, oh, well, this one equals 7, that's done. What needs to go here so that it equals 4? Ah, well, 12. 16 minus 12 is 4. So I know, oh, x equals 12. Does that work? Sure, when I put it back in there, 0 minus 7, 16 minus 12, that's 4. Now that turned out pretty easily, but I'm going to show you when it does not, you can still solve it. When it doesn't come out, well, that's a pretty easy equation. And you can still solve it by, hopefully, maybe you remember, cross multiplying and dividing, okay? So in this case, you would cross multiply. 7 times 4 is 28, all right? And that has to equal this, right? 7 times 16 minus x. So I have 28 equals, and I have 7 times 16, 112, minus 7x. Subtract 112, subtract 112, right? And I'm going to get 28 minus 112, negative 84 equals negative 7x. Divide by negative 7. Look at there, x equals 12. So if you have this simplified, great. You can plug it in and see, oh, I know what fits there. X has to be 12 to make that slope 7/4. In the event that you get a more complicated problem for slope, and you will, you can use cross multiply and divide to solve for x still. Either way. So, challenge, do 29. You can do it, then check it in the back of the book. But this is how you solve it when you're missing one of the coordinates. I think you got it. As always, come see me on Google Meet. 1 to 2 if you have any questions. Have a great day.